Hi, I would like to discuss TOK title. How can we be sure that patterns we discern in the world are genuine features of reality and provide a sound basis for mathematical knowledge? Claim. Patterns observed in the natural world can provide a genuine basis for mathematical knowledge as they reflect inherent structures within reality. For example, the Fibonacci sequence appears in various natural phenomena, such as the arrangement of leaves on a stem or the pattern of seeds in a sunflower. This recurrence suggests that these mathematical patterns are not mere coincidences, but rather fundamental aspects of nature. The consistency of such patterns across different contexts supports the claim that they are genuine features of reality, allowing mathematicians to develop theories and models that accurately describe the natural world. Knowledge question 1. To what extent can observed patterns be considered objective truths about the world?
Counterclaim.
However, some argue that patterns we perceive may not be genuine features of reality, but are instead imposed by human cognition. Our brains are wired to recognize patterns, even where none exist, a phenomenon known as apophenia. This cognitive bias can lead us to erroneously identify patterns, making us believe that they represent a fundamental aspect of reality, when they might not. For instance, the perception of constellations in the night sky is a pattern recognized by humans, but does not correspond to any inherent structure in space. Similarly, seeing shapes in clouds is a subjective interpretation that does not reflect any genuine, underlying pattern. Thus, while patterns can guide mathematical discovery, they do not always guarantee an accurate representation of reality. Knowledge question 2. How does human perception influence our recognition and interpretation of patterns? Synthesis. The debate over whether patterns represent genuine features of reality highlights the complex interplay between observation and interpretation in the development of mathematical knowledge. As the physicist Richard Feynman once said, mathematics is not just a collection of arbitrary rules, it is a representation of the structure of the universe. This quote underscores the belief that mathematical patterns can reveal the underlying order of the natural world. However, to ensure that these patterns are reliable indicators of underlying truths, they must be subject to rigorous empirical validation. This involves testing whether the patterns consistently apply across various contexts and scenarios, thereby demonstrating their universality and objectivity. Conclusion. By critically examining the patterns we discern, we can better understand their role in shaping mathematical knowledge. Acknowledging both the potential insights and limitations of pattern recognition is crucial in our pursuit of a more profound understanding of the natural world. Through a careful balance of skepticism and acceptance, we can discern whether patterns are indeed features of reality or constructs of the human mind, allowing us to develop a more nuanced appreciation of how mathematical knowledge is grounded in the reality we perceive.